This is 2-3 scientific notation guided. First question is scientific notation and texting. What are the similarities? So scientific notation takes a very large number and makes it in a standard form where everybody can understand, takes up less room. Texting, at the early stages of texting, you were limited by characters, and so they also shortened it. So shortened with same information. How is scientific used in real life? Astronauts, scientists, medical field, and a lot of scientists that do deal with microscopic numbers. So if I had a number 93 with a gigantic amount of zeros, you know, I wouldn't want to retype that over and over, but I could do 9.3 times 10 to the 3, 6, 9, 12, 13th. And then we would know because of such a large exponent is such a large number. Write in standard form. The decimal is here, 7. 1, 2. I count 1, 2, 3, 4. Oh, need another one. So then I come back and put the commas. Here's a nice one. And somewhere in our notes we learned that 10 to the 0 power is 1. So 10 to the 0 power is 1. That is 8.23 times 1. This says don't move it at all. There we go. That is 8.23. Notice this negative exponent means I'm adding zeros to make it a decimal. So it's going to have a 0.17. I put 1 0, so I went 1, 2. So I need another one. So 1, 2, 3. Okay, here we go. This is a blank and not a negative. So my decimal would be here. So it's 5.02. How do I get there? That's 1, 2, 3, 4 times 10 to the 4th. 3.41522, because it just needs to go there. It's a decimal number, so it's -1. It's got commas. It's a positive number. It's going to go right there. Most scientists, I will accept 1.35 times 10 to the 1, 2, 3, 4, 5. You actually don't, +5. You actually don't have to write all the digits. This is normally in scientific journals times 10 to the -1, and that's more than fine with me. We're writing this in scientific notation, so the decimal has to go here. It's 2.0 times 10 to the positive or negative exponent. It's going to be a negative exponent because it's a decimal and a very small number. 1, 2, 3, -3. This one is 1.00 times 10 to the don't move it at all. Here I'm going from here all the way here. 1 times 10, 1.0, sorry, times 10 to the 1, 2, 3, 4, 5. After a while, you're going to notice, and some people just start memorizing what exponent goes with how many place values. 12, not really a scientific notation because we're not really doing it very much, but it would be 1.2 times 10 to, and all I did was move it from here to here, so that's 1. 1, there we go. We didn't move it. This is not really a microscopic number. It takes the same amount of room to write it, but if we were to write it in scientific notation, it would be 3.4 because I need to have one leading digit. Then it would go 1, 2 times 10, 2, not positive because it has a decimal, so a -2. Evaluate means plug and chug. So A is 2, B is 4, C is -1. This is 2 to the 4th plus 2 times 4 minus -1 squared. So I'm going to come inside this parentheses and mess with this parentheses. This is a -1 times a -1. A negative times a negative is a positive. So I'm going to scoot over here and say 2 to the 4th plus 2 times 4 minus 1. And all I did was take care of this part right here. Then I'm going to do my parentheses. 4 minus 1 is 3. Then I'm going to do my exponents. I'm actually going to come over here and go 2 times 2 and 2 times 2. There's 4 of them. 2 times 2 is 4, times 2 is 8, times 2 is 16, plus 2 times 3. Then I'm going to do multiplication, so 16 plus 6, and that's 22, and that's your answer. That takes you through 2-3 scientific notation and guided.